This lesson will be talking about solving linear equations. All right, so we're all pretty familiar at this point that we solve equations, and equations just mean that we have equal signs, okay? And we'll get into word problems where we can write equations from word problems, but for right now, we're going to practice just solving equations. The specific type of equation that we're going to solve is a linear equation. A linear equation is an equation which contains a variable which is not raised to any power other than 1. So example of a linear equation would be like x plus 2 equals 3. Or 2 times x plus 1 equals 4x plus 6x divided by 2. A non-example would be something like x squared is equal to 4, or x to the third is equal to 27, or x plus 1 over x equals x divided by 2. You might have to look at that one a little bit closer. But if the variable is raised anything other than 1, then it's a linear equation, and that's what we'll be focusing on now. To any equation, remember equation comes from the word equal, right? There's an equal sign. And on any equation, there's a left-hand side and a right-hand side. A lot of times we'll use LHS to refer to the left-hand side and RHS to refer to the right-hand side. And when we have an equation, and if there's an unknown to this equation, it's going to satisfy the left and the right-hand side. So for instance, let's say that I have 3x plus 7 equals x minus 5. Well, if I told you that the solution is x equals 2, then you need to make sure that the left-hand side is equal to the right-hand side. So what we do is we start off and we look at either one, left-hand or right-hand side, but we'll look at each one individually. So the left-hand side is 3 times 2 plus 7, which is equal to 6 plus 7, which is equal to 13. And I'm going to write this sign right here. This sign right here means therefore. So we need the right-hand side if this is a solution to equal 13 at the very end. So 2 minus 5 is equal to negative 3. Uh-oh. That doesn't work. Because if x equals 2 was a solution, then this right here, they would be equivalent at the end. So maybe my question is, what would work? Well, let's try x equals negative 2. Again, we'll start with the left-hand side, which is 3x plus 7, and the right-hand side, which is, so by the way, never mind. So, which is x minus 5. I'll come back to that in just a second. So again, I want to check if x equals negative 2 is a solution. So, is not a solution. So, is not. So this is not a solution, okay? Because the left-hand side and the right-hand side don't equal each other. So I'm going to check the left-hand side again. I get negative 2 here. So I have 3 times negative 2 plus 7. Negative 6 equal plus 7. That gives me a negative 1. Don't forget your therefore signs. And so let's see if this works. X minus 5. So I plug in negative 2 minus 5. Negative 2 minus 5 is a negative 7. Does -7 and -1 equal each other? No. You can see here that it becomes quite difficult to just try and guess different solutions to this equation. That's why there is a method to find the solution instead of guess and check. All right, and here's how we're going to find this way of solving for our solutions. Let's say here that we have to first recognize how we built up the equation. So let's say, for instance, at the beginning here, we are builders. I have x equals 5. What I'm going to do is I'm going to use properties of equality. Now, the properties of equality, you probably know them, but these are formally written down. Just take a moment and check all of these properties. Pause the video, write them down. Again, these are properties that you basically already know, and the properties that you've used to solve equations so far, but these are just formally written down. And essentially, whatever you do to the left-hand side, you need to do to the right-hand side. That's all these are saying, okay? So I'm going to use those properties of equality. The first thing I'm going to do is I'm going to use the addition property, and I'm going to add. Whatever. What do you want to add? Let's add 7 to both sides. Equal 5 plus 7. And I'm going to write down what I'm doing over here. So I add 7. Okay? Next, what I'm going to do is I'm going to, what do you want to do? Let's multiply by 2. So now, and this next step, so we'll call this 1, this is 2, I'm going to multiply everything by 2. And 5 plus 7 simplifies to 12. So here I have my final equation. 2 times x plus 7 equals 24. Now, if you just had this equation, you would write some ways, you would maneuver this equation to find what x equals. But because you saw the buildup, you know that x equals 5. Why do we know that? Well, because we use the properties of equality to just continue building up this equation. Now, let's say that you had this equation right here and you didn't know this part. What we're going to do is you need to break down, instead of building up, we're going to break down, and we're going to break down by isolating the unknown with inverse operations. So here it is. So I have 2 times x plus 7 equals 24. Now, pay close attention to what happens up here. You're going to go in the inverse operations. Inverse means reverse order and opposite operation. Okay? So watch. I'm going to start here at the end. The first thing I'm going to do is I'm not going to multiply because I'm going in reverse order. So I'm starting with number 2. I'm going to do the opposite operation. The opposite operation of multiply is divide. So I'm going to divide by 2. So in this first step here, I'll divide this equation, everything by 2. And I'm going to simplify that. Oops. So 2 divided by 2 just goes to 1, and I'm left with x plus 7 equal 12. And now the second thing I'm going to do is we multiplied by 2. The first thing I did was add 7. So the opposite operation of adding 7 is subtracting 7. So I'm going to subtract 7 from each side. And we'll make that step 2. And you can see what I have is x equal to 5. And again, we did that because we are trying to isolate the unknown. That is, we're going to get the variable that we don't know on one side. And we're using inverse operations. That means reverse order and opposite operation of how it was built up. Now, that's using the simplest case. Let's say that we have an equation with a repeated unknown. That is to say that notice in this equation that we have two unknowns on both sides of the equal sign. The only thing that changes is this first step, which it says, if necessary, expand and any brackets can collect like terms. That's the only thing that changes. After that, you just need to do, again, what we did here, break down by isolating the unknown and doing inverse operations, which is just doing reverse order of buildup and opposite operation. So the first thing I'm going to do is I'm going to say, oh, okay, there's a variable on both sides of the equation. So what I need to do is I need to expand any brackets. Are there any brackets? No brackets. Collect like terms. Now I need to collect like terms. Okay, I'm going to go do that. 15 minus 2x equals 11 plus x. Now, in order to get my like terms, collect them, they need to be on the same side of the equation, right? So here are my two like terms, my numbers, my constants, and my variables. And, well, I want to get I'm going to isolate the variable. So I'm trying to get the variable together on one side. Well, you can go either way. You can go left or right. I'm just going to go add 2x. And remember, you got to do it to both sides. And that gives me 15. Now, minus 2x plus 2x, that just goes to 0x, but I'll write it here, equals 11, and then, remember this is 1x, so 1x plus 2x is 3x. Now, pause here for a second, because anything times 0 is just going to be 0. So what I'm going to do actually is I'm just going to erase this. Okay? Now I have 15 equals 11 plus 3x. Now I want to get the variable on one side. I want to get it by itself. Isolate. So I'm going to get rid of this this 11. So I'm going to subtract, do the opposite of adding 11. And over here on the left-hand side, I get 4 equals 3x. Now we're close. We're close to isolating this variable. Now, we just need to get rid of this 3. Well, in order to get rid of the 3, we do the inverse operation. The inverse operation of multiplication, because it's 3 times x, is division. So x is equal to, x, that goes to 1, which is after. We just want the value of 1x. 1x is equal to 4 over 3. You could also say x is equal to 4 over 3. These mean the same thing. So the only thing different between this example and the example up here is that you have an unknown on both sides of the equation. That's it for this lesson.